Okay, so let's go ahead and keep going on with the notes. Again, we will talk about the notes in class. Please ask me if you have any questions. I want to help you out the best I can. But let's go ahead and video a few pages tonight. That way you can get through those as well. I know it's a lot of notes. Remember, this is a big unit. Okay, so now we're on part 7, characteristics of 3 types of bonds. So we've got metallic bonds, which are going to be metal and metal. Okay, so when metal atoms, says here, frozen together in a solid state, they're stuck together. It's a solid piece of metal, right? Physical properties are as followed. Well, first thing is, if we have a metallic bond between metals, okay, the outermost electrons wander freely through the network of atoms. Okay, they are very mobile. Can't speak. They are movers. They can move. Those valence electrons can wiggle and move around. It says here that free electrons move in response to the electrical fields. Hence, metals are good conductors of electricity because those electrons can freely move all the way around and wiggle all over the place. Free electrons can transmit heat, and we call this kinetic energy rapidly. Hence, metals are good conductors of heat. Motion is going to cause friction when there's moving going on, even if we're talking about electrons moving. Haven't you touched your cell phone after it's been on for a while? Or have you touched the back of a computer? Right? Those computers, you hear those little fans turning on, and that's because they're trying to cool it down because the electrons are passing through those wires, and when they're moving, friction is occurring. And when friction occurs, then it heats up. That object's going to heat up. You ever touched a wire from something that's been running? The electricity's been going through that wire for quite some time. You touch the wire starts to feel a little warm. Okay, that's because from the friction of the actual electrons moving. The next one, the layer of atoms in metals are hard to pull apart because of what we call the sea of electrons holding them together. Hence, metals are tough, but individual atoms are not held to any other specific atom. Hence, atoms move easily past one another. Okay, so what they're trying to say is, over here, letter A, they're trying to tell you how they move freely throughout. This may be the electron from this AU atom over here, and then it's wiggling his way all the way around to over here. And this electron can wiggle and move its way over here. And this one is, they're just moving all over the place. Literally all over the place. And because they can do that, that's the reason why they're such good conductors of electricity, because the electrons can easily and freely move. Okay, so on letter B, free electrons move in response to the electrical field. Meaning if we have negative and positive, those negative electrons are going to try to move that way, right? They're going to try to move towards the positive end. Opposites attract because of this. Part C over here, free electrons can transmit heat. Because when those electrons are moving past, they're causing vibrations, and those vibrations are causing friction. That friction causes heat. And then on letter D, it says here that the layers of atoms are hard to pull apart because they are one big giant piece of metal. We call it the sea of electrons. There's electrons over here moving, and electrons over here moving, and electrons over here. And because they're layered and smushed together, it's hard to just separate those metals, right? Yeah, you can break them apart, but it's because they're layered and stacked up on top of each other. But even though that they're layered and stacked up on top of each other, those electrons can freely move, and we call that the sea of electrons. It says here, just a small little recap of what we just said up here. What are some properties of most metals? Okay, and we call this metallic bonding. If metallic bonding is occurring, they are going to be malleable. Most metals. Okay, that's the key word, most. They are going to be ductile, meaning that you can form it into thin wires. They have what we call a sea of electrons. They have a very high melting point, a very high thermal conductivity, high electrical conductivity. Next part here, well, what is what we call an alloy? Haven't you heard? Some of you have heard of that word before, an alloy. An alloy is actually a mixture, I should say, of two or more metals. It's produced through physical change, even though because of it's just melted together. The two types of metals are just melted together. Because the two metals are evenly mixed, it is commonly known as a homogeneous mixture, or what we call a solution. Most of the time we think of a solution as a liquid, but an alloy is actually a solid solution. Okay? And then we have this next part over here. It's still, we're just still recapping. Okay? Ionic bonds, and then we're going to recap covalent bonds, and then we're going to get into the naming. Okay? So ionic compounds. Ionic compounds, don't forget, are going to be metal ions and non-metals ions that actually transfer electrons. What do they not have when we do the drawing? They do not have a line that connects them. The line represents sharing. When it comes to metals and non-metals, they don't share. They give up electrons and they accept electrons. They transfer electrons. So we can draw an arrow that represents the direction that the electrons are going to transfer, but we do not draw a line. Now, some physical properties of ionic compounds is that they are held together by their attraction of that positive / negative charges. Right? We have anions and cations, and those opposite charges helps hold that bond together. Now, another physical property is that they actually are salts. When they come together, they become a solid at room temperature, and they crystallize. And they become salts, like sodium chloride, NaCl. A metal and a nonmetal come together, bond, and they crystallize, and they become salts. They have the highest melting points. Next one, they have the strongest of all the bonds. And when dissolved, in H2O, it produces ions which produce electricity. Okay? And if you stop and think about it, remember the anions and cations, the positive and negatives? Okay, because of those negative electron charge, we're able to, electricity is able to pass through those ions. Okay, covalent compounds. Remember, that is nonmetals, a nonmetal and a nonmetal that actually they share electrons with each other. And how do we represent that sharing when we do the drawing? Through a straight line. And that straight line indicates that I have one, you have one, but together we have two. Okay? The next one, they have the lowest melting point. They are very weak bonds. Next one, they can be a solid. They can be liquids. They can be gases at room temperature. The next one, it does not produce electricity when dissolved in H2O. And then the last one, only polar bonds will dissolve because of that positive and negative charge in H2O, because H2O is polar, right? Like dissolves like. Polar is going to dissolve polar. And because H2O is a polar compound, then only other polar compounds will dissolve in H2O, meaning that it's got to have that positive negative kind of charge in it. Okay? Now, like I told you in the beginning, this is actually two sets of notes together. This section here is the first set of notes. Down here, starting off with the naming covalent compounds, I'm just going to just draw a line. That actually begins the next unit of notes right there. And we can definitely start those soon, okay, for us.